Hi. In this class, we will explain the basic concept of traceroute, how the traceroute utility works, and how it is utilized in the context of networking and network monitoring. The traceroute is a utility that records the routes between two devices on different networks. On modern Unix and Linux-based operating systems, the traceroute utility by default uses UDP payload with a destination port number starting at 33434. The Windows utility uses ICMP echo request, better known as ping packets. Some firewalls on the path being investigated may block UDP probes but allow the ICMP echo request traffic to pass through. There are also traceroute implementations sending out TCP packets, such as TCP traceroute or Layer 4 trace. In Microsoft Windows, traceroute is named Tracert. A new utility path ping was introduced with Windows NT. It combines ping and traceroute functionality together. All these traceroutes rely on ICMP Type 11 packets. Let's take an example to understand more. Right now I am on router A and trying to trace the path for IP address 192.168.10.2. This IP address is assigned on router D. The traceroute utility uses ping or echo request method to check the route between the devices. Initially, the traceroute sets the TTL value 1 in the field of IP header. In this case, router A sends an ICMP packet to router B and also sets the TTL value 1 in the field of IP header. Always remember, when a router receives an IP packet, it decreases the TTL value by 1. If the TTL is 0, it will not forward the IP packet to the next hop. In our case, once router B receives ICMP packet, it decreases the TTL value by 1. Router B notices that the TTL value is now 0 in the IP header after decreasing the TTL value by 1, and it sends back an ICMP time exceeded message to router A. Now router A will use the source IP address of router B and update the traceroute table based on the ICMP time exceeded message received from the first hop, or router B. Now router A increments the TTL value 1 in its original IP packet. At this time, the TTL value is 2 in the IP header, and router A resends the ICMP echo request packet. As soon as router B receives ICMP echo request from router A, it decreases the TTL value by 1. The ICMP packet still has TTL value 1 after decreasing the TTL value 1 because it was set to 2. Now router B looks up the destination IP address in its routing table and forwards it on to the next router because destination IP address does not belong to router B. When the ICMP packet arrives at router C decreases the TTL value by 1 from the total TTL value. Now router C notices the TTL value is 0 after decreasing the TTL value. At this point, router C cannot send the ICMP packet to the next hop because the TTL value is 0. As said, once the TTL value is 0, the router sends ICMP time exceeded message back to the source device. Router C sends back an ICMP time exceeded message to router A, and now router A will use the source IP address of the ICMP time exceeded message to display the second hop. The router A repeats the same process until it reaches the destination device. Now router A increments the TTL value 1 in its original IP packet. This time, the total TTL value is 3 in the IP header, and router A sends the ICMP echo request packet to the destination 192.168.10.2. Router B receives an ICMP echo request. It decreases the TTL value by 1 and looks up the destination IP address in its routing table. As router B knows, the destination IP address does not belong to itself and it forwards the IP packet to the next hop. At this stage, router C receives an ICMP echo request packet. It decreases the TTL value by 1 and looks up the destination IP address in its routing table. As router C knows, the destination IP address does not belong to itself and it forwards the IP packet to the next hop. Now the ICMP echo request packet has reached router D. The router D performs the usual actions. It decreases the TTL value by 1 and looks up the destination IP address. Router D notices that the destination IP address of 192.168.10.2 is its own, and it is assigned to its own interface. Now it does not need to forward the packet to the next hop, also the TTL value of 0 has no effect. Router D sends the packet to the UDP process. UDP examines the unrecognizable port number of 35,000 and sends back an ICMP port unreachable message to Router A using type 3 and code 3 messages. Router A receives the ICMP port unreachable message from Router D. The trace route program uses this information and displays the third hop. The trace route program also recognizes this port unreachable message as meaning this is the destination it was tracing. Getting the ICMP port unreachable message, it knows this is the final hop and does not send any more traces or echo requests.